Welcome! We're going to be doing a little bit of puzzling here today. You are in charge of picking any counting number that you want. I would make things easy on yourself if I were you. You'll take your counting number, multiply it by 3, then take that answer and subtract 12, then take that answer and divide by 3, and see if you can find a pattern with what is happening between the beginning, where you picked your number, and the end result. So what happens to the original number each time? And when you do this kind of work, this is called inductive reasoning, where you try a few examples and see if you can come up with a conclusion. I encourage you to pick numbers of your own and work your way through a few of these. I am going to pick 5, 10, and 12 for my examples. So if you want to use those, go ahead and pause the video, work out what you think will happen for each of the remaining steps, and then we'll join up again in a few moments. Here's my first column filled in. When I picked the counting number of 5, I ended up with a result of 1. It might be the case that I take my initial number and divide by itself to get 1. Or maybe I take my initial number and divide by 5 and I get 1 in this case. I don't have enough information to make a statement about a pattern just yet. So I need the other 2 columns at least. Here are my second and third columns completely filled in. And now when I'm looking for a pattern, I need to take 5 to start with and end up with 1. And then I need to take 10 and end up with 6, and take 12 and end up with 8. And now that I have a few examples, I can start to see a pattern. I think it is the case that for any number I pick, I should subtract 4 to get the end result. So what happens to the original number? It's decreased by 4. That is inductive reasoning, where we use examples and try to spot a pattern. When we go ahead and prove this algebraically, that will be considered deductive reasoning. So let's do that next. This will be the algebraic proof. To do the algebraic proof, instead of picking a specific counting number, we will pick a generic number, like n or x. I'm going to use n in this case. So I start with n, that's me picking any counting number, multiply that quantity by 3, so I'll have 3n, then subtract 12, minus 12, and then divide that whole quantity by 3. I end up with 3n minus 12 all divided by 3. And that's nice, but we need to do a bit of simplification on this. We can do division on both terms, division in 2 places in this case. And when we do that, and we should do that, we end up with n minus 4. And that means that we started with a value of n, remember, and we ended up with a value of n minus 4, which is our n value decreased by 4. So applying our rules and applying some algebra takes us from start to finish.